Hello, ladies and gentlemen. This is Mr. Green. This is another in my series of recordings on geometry. We're making our way through Unit 3. We're up to the third set of lessons in there, and they deal with triangle similarity. Well, we've already talked about the fact that we were going to have triangles that are similar to triangles, right? And we talked about having to find all the angles being equal to each other, all the corresponding angles in these two triangles being equal to each other, and then finding that all the sides are going to be in proportion to each other. Oh my gosh, it's so much work. If I'm trying to prove two triangles are being similar to each other, I don't want to have to do all this work. I am basically a lazy person, and I really don't like doing that much work. It is just too much, Mr. Green. I agree. I agree wholeheartedly. And so, you know what? Just like when we were trying to prove triangles as congruent, we have these nice little theorems. Okay? We're going to use a couple of little two-letter theorems this time. Instead of the three-letter ones for congruence, we're just using two-letter ones here. Okay? This first one is going to be called angle-angle similarity. It says if there are two triangles, if two angles of one triangle are congruent to two angles in another triangle, then the triangles are similar. Much easier to do. All I've got to do is find two angles in the triangles as being congruent. So if I look at this triangle here, I've got a 30-degree angle here, I got a 30-degree angle here, and I've got a 60-degree angle here and a 60-degree angle here. That's two angles. One, two, one, two. Two angles in one, two angles in the other. They're congruent. That means these two triangles are similar to each other. Yes, that means the sides are in proportion. And if I had any questions about the sides, I could now use those ratios to get this done. You know what? There's another way they kind of show this to you. See this one here? We've got this one 30-degree angle. And I can see one 60-degree angle here and a 60-degree angle down here. That's actually two triangles, isn't it? I've got the triangle QUT, and I've got the triangle QSR. And those two triangles are going to be similar to each other in proportion. I could set up ratios. That is what we're talking about with angle-angle similarity. Okay? Wait a second. This one's got three letters in it. It's going to be confusing. I've got side, side, side. That was one of the same things that we had with the congruence. I know, but it's not going to be the same because we're going to have two triangles that don't even look like they're congruent to each other. They're completely different. But if I can prove that the ratio of the sides, if the proportions amongst all these things are the same proportions, I have to have three of them that I'm checking out there. So one side is proportion to, so this one is in proportion to this one, and this one is in proportion to this one, and this one is in proportion to this one. If I can prove that, then the two triangles are similar. How does that help me? That tells me the angles are equal. Ha ha ha, I didn't even have to look at anything on the angles to know the angles are equal. That's one of the good things about proportionalities. We can use it doing that. It's really nice. It helps us a lot. There's another one here. Side, angle, side. It's the same concept that we used in triangle congruence. I'm sorry. We have to have an angle between two sides that are in proportion to each other. So in other words, I've got 6 is in proportion to 2. That makes a 3, right? And 5.4 is in proportion to 1.8. Yep, that's a 3 as well. And I've got this angle down here that's 70, and that one's a 70. Do I have side, angle, side? Not yet. Why not? Well, this side and this angle, it's not in between the two sides. I've got to do this side over here, 4.5 and 1.5. That's a 3 as well. Now I've got this side angle and that side. I've got to have the angle in between the two sides to make it work. Okay? And I did that across two triangles. Cool. I appreciate you guys sending me the fact that you're in geometry if you send me questions. If you have questions, please come to tutoring on Tuesday, Wednesday, or Thursday. I would be glad to try to help you with your problems. I know there's some people in there that might be doing Algebra 2 or might be doing some other things, but please come on in and I will answer your questions. I try to get to everyone before we get out of there. Okay? So I look forward to seeing you next time.